Okay, so you should have done this already. So just to go over this real quickly here, the mean of p hat is equal to p, standard deviation, this formula right here. Here's your ones for the means, x bar. Remember these formulas right here are only accurate if n is less than 1/10 in n. That was what we checked for the independence check. The sampling distribution, if I'm talking about the sample proportion, so if I'm talking about the sampling distribution of p hat, it's approximately normal when n times p is greater than or equal to 10 and n times 1 minus p is greater than or equal to 10. If I'm talking about the sample mean, it's approximately normal if the population is normal or the central limit theorem can apply, so the sample size is greater than or equal to 30. What does it mean for the T procedures to be robust? So if it's robust, if you remember, it was the normal check back in chapter 8, where the normal check maybe wasn't met, so we didn't know if the population was normal or we didn't know if the sample was greater than or equal to 30, so the central limit theorem could apply. So we would look at a graph, and we were just making sure that we didn't have any strong skew outliers. So, and remember, it wasn't that we were trying to ensure that the graph looked perfectly normal. Was there anything on the graph that would make us think the population might not be normal? Here's your, remember, if you're finding the difference in two variables, you take the difference in the means. If you're finding the difference in two variables to get the standard deviation, you're still going to add your variances. If you have a standard normal curve and you want to find the probability that z is less than that number, then you can just use your normal CDF command. If you have a t distribution, so if I want to find the probability that I'm greater than that, I need to know the degrees of freedom. So I can just use the tCDF command. It works just like normal CDF. So this one right here, if you're trying to do the sugar one, so packet, so there's going to be 4 packets that are going to go into the T here. And so T is capital T for my TEAT. So T is packet 1 plus packet 2 plus packet 3 plus packet 4. So the mean of all those, it would just be 2.17 plus 2.17 plus 2.17 plus 2.17. So I could just have 4 of those. So there's my new mean. The standard deviation, it would really be 0.08 squared plus another 0.08 squared plus another 0.08 squared plus another 0.08 squared. So there's 4 of them. So that's 0.16. So then the probability that my total amount of sugar that is between 8.5 and 9 follows a normal distribution because each of the original packets were normally distributed with this mean, this standard deviation. So we can use normal CDF. So there's a 84.7% chance the T will taste okay. Short answer, so general form for confidence interval, statistic plus or minus the critical value times the standard deviation of the statistic. General form of the test statistic, so it's statistic minus the parameter divided by the standard deviation of the statistic. All right, chapter 10. It's very similar to chapters 8 and 9. The only thing that's different is now we have 2 independent. They're independent. If we had 2 dependent samples, that's a matched pair scenario, which was back in our 1 sample procedures. So we have 2 independent samples. And then they're also throwing a section here on comparing all the tests that you've learned up to this point. Okay?